Halfway through this set of videos, now we're on problem number 65. Okay, so very poorly drawn, here is the circuit for number 65. So now I don't know I2 and R2, and that's what I'm charged with finding. And so this, it isn't just straightforward, I have to actually work backwards through some of this. And so, if I don't know where to start, let's just draw or write the equation for our loops. So, in this blue loop going through R2, I have this equation. Starting with 6, I subtract the voltage drop across 2, and I also subtract 4 volts, because it tells me that the voltage drop across this 24 ohm resistor is 4. And I know that once I get past that, my voltage has to be 0 because there's nothing else to go through. So that equals 0. Now 6 minus 4 is 2, so I get 2 minus delta V2 equals 0. So I know the potential drop across this resistor 2 is negative 2 volts. Now using what we know about parallel circuits, if the voltage drop across R2 is negative 2 volts, then I know the same potential must be across this 20 ohm resistor. And so if that's true, then using Ohm's law on the 20 ohm resistor, I can get that 2 ohms, or 2 volts, which is the potential drop, is equal to the current going through that 20 times 20. And when I divide 2 by 20, I get 0.1 amps. So I know there's 0.1 amps coming out of that junction. And so that 0.1 plus I2 gives me my total current. So that's one way I can solve for I2. But the question is, how do I get this total current? Well, if we look here, I'm given a resistance and a potential. And so if I use Ohm's law, the potential is equal to current times resistance, and I get that I here is equal to 0.167 amps. And if we think about this, the total current coming out of this battery came into this junction and split up into 0.1 and whatever I2 is. Now when they get back to this point, 0.1 and whatever I2 are come back together to give me my total current. So my total current is running through this resistor, and I just found it. My total current is 0.167. So if I come over here and say 0.167 is equal to 0.1 plus I2, then I2 is just 0.067 amps. So I found one of the variables I'm interested in. Now how do I find R2? Well, delta V2 is equal to I2 times R2, and let's fill in what we know. We found earlier that the potential drop across R2 was 2 volts. My current is 0.067, so I can easily solve for my R2. And so when you do that math, you get R2 is equal to, well, I got 29.9 ohms. Now this is going to be different depending on what you used for your currents and how you rounded, but as long as you get something around 30 ohms, you should be correct. So now we have our two answers, I2 and R2.